Alright, so we're looking at lesson 2.3, which is solving quadratics by factoring and square rooting. So factoring is the process of rewriting an expression or equation as a product of its factors. And then we have the zero product property, which basically states that for any real numbers, also including terms, if a times b is equal to 0, then either a or b, at least one of them, has to be equal to 0. So if you multiply two numbers together and you get 0 as a result, that means that one of those two numbers that you multiplied together had to be 0 in order to get 0, right? That's the only way you can get 0 is to multiply by 0. So that's what the zero product property states. And we use that in factoring to solve for roots or solutions. So we have the GCF method, which we just talked about. We have AC method, which is basically what I taught you guys with the multiplication. I'll show you again what that is. Factoring by grouping, which we haven't talked about yet. We did talk about difference of squares, and we talked about square root. So the only new one that we haven't talked about is by grouping. So that's the only new one we're really addressing in this lesson. So solve by factoring out the GCF. Now we're doing the same thing we were doing before, however, we're going to have to do a little bit of manipulation first. So whenever you want to solve by factoring out a GCF, you need to get all the terms to one side of the equation. So in order to do that, and if you guys need extra paper for any reason, I do have some over there on that table, so if the notes are small, that's an option. So I'm going to add the 9x to both sides. So you want to get all the factors and terms to one side. So that leaves me with 6x squared plus 9x equals 0. So that's the first thing you want to do. And we call this standard form because you've gotten everything to one side. Now from here, we want to see if we have a GCF of anything on my left.
No. 3.
We have an x, but we also have a number. 3. We have 3x, right? So it's going to be 3x times, then I divide everything by 3x, which becomes 2x plus 3, right, is equal to 0. So that is the factored form. So I was able to divide 6x squared by 3x to get 2x.
So you just take the 3x out of both of them?
Yep, that's how you factor out the GCF. So then from here, we use what's called the zero product property. So when these two numbers, like this 3x and this 2x plus 3, this thing indicates they're being multiplied together, right? And we know that the result of their multiplication, okay, is equal to 0. We know the result of their multiplication is equal to 0, which means that in order to get 0, there's two ways we can get 0. Either this term had to be 0, or this term had to be 0. So we're going to find the two times that that could occur. So what we do for the zero product property is you take each of the products and you individually set them equal to 0. And when you do that, you then solve for x, just using normal solving equation methods. So to solve for x over here, I divide both sides by 3 and I get x is equal to 0. And over here, I have to subtract 3 from both sides. That gives me 2x is equal to negative 3. I divide both sides by 2, and I get x is equal to negative 3 over 2, which is negative 1.5.
So, which I thought you lost me when we got to 3x, and in parentheses 2x plus 3 equals 0. So after that, do we, like, you see where you have the equation 3x?
You get to this part, right?
Yeah.
Okay, so this is what the zero product property states. If the product of two terms is equal to 0, at some point, in order to get that equal to 0, one of these terms had to be 0. So there's two ways that can happen. Either the first term is 0, or the second term is 0, meaning I set them both equal to 0 to find those two ways that are going to give me 0.
Okay.
Okay, that's always what you do with the zero product property. So this is actually a quadratic, and this is where it hits the x-axis.
Okay. But, so after you're done with it, you did 3x equals, you just set 3x to 0?
Yep, you set each of the two products equal to 0. And from here, you put in your solution. So your solution here is always going to be 0 for the y, because we this right here was represented the y, it's 0. And the x is going to be the two x's that you just found. So 0 and negative 3 over 2.
Did you just cancel out the 3x?
Well, when I divide, 0 divided by 3 is just 0.
Mm-hmm.
Yes?
Does it matter if we simplify the negative 3 over 2 to negative 1.5?
It's fine as long as the decimal's terminating. It doesn't repeat or anything like that. I don't care. So what I do want to show you really quickly is I'm going to pull up on Desmos graphing so you can see how this actually looks in terms of a graph. So this represents a quadratic, okay? Y equals 6x squared plus 9x. So if we look at this quadratic as a graph, okay, if we zoom in here, we see that my two solutions, which I hit the x axis, are 0 and negative 1.5. So that's how it kind of comes full circle to what we've been doing the last few days. So, all right. Anyways, let's try another one. So for this one over here, first thing we look for is the GCF. So what is the GCF here?
7x.
Good, 7x. I factor out a 7x, I get x minus 3 is equal to 0. When I have the product of two things equal to 0, I set each piece equal to 0. Okay? So that's going to be 7x equals 0 and x minus 3 equals 0. Divide both sides by 7, I get x equals 0. I add 3 to both sides, which gives me x equals 3. My y coordinates are always 0 for a solution, and I just put in the two x's that I just found.
Y coordinates are always 0?
When you find solutions, when you set something equal to 0, yes, because effectively that's what we call, we're basically replacing the y with 0, yes. Any questions on this? Okay. Alright, so now we're going to do factor by grouping. So by grouping is a little bit tricky, so it takes a little bit to get used to how to do it. But what you do is you're basically grouping terms together because you can't factor a GCF out of the whole thing. You're going to look at pieces that you can factor out a GCF out of. So let's pretend we're looking at this expression as separate expressions on the left and the right of the green dotted line. What can I factor out on the left side of the dotted line? 8, also an x. I can factor out an 8x over here, right? And when I do that, I'm left with 4y plus 5b. And what about on this side? What can I factor out over here? Good. I can factor out a negative 3, right? And an a. So when I do that, that becomes negative 3a times, and then what is it going to become? It's going to become a positive 4y plus a 5b.
Why is it plus 5?
Because I factored out a negative, yeah. So now that you've seen that, let's say I erase this dashed line here. Now we just have a somewhat factored expression. Now, both of these expressions have a term in common. It's just probably not one that you see very obviously. Both of these expressions have this term right here. You see that? So, I can actually factor this term out. So this becomes 4y plus 5b times 8x minus 3a. And that would be factored form. It's kind of weird, I know. Alright, so tell me where you guys got lost. So, are you good with this part right here, how I did this?
Wait, where did the 8x and the negative 3
Because you see how they're the same in the middle?
Yeah. So basically what I did was, here's like a good way I can explain it to you. Let's pretend that all of this in the blue, let's call it by a variable a. No, we have an a in there. Let's pick something that's not in there. What? Z? So let's say that 4y plus 5b is equal to z. Okay? So I'm going to go through and replace all of this with z. So that gives me 8xz minus 3az. Well, what can I factor out of both of those terms? What do they have in common? A z. So I can factor the z out. And when I do that, I'm left with 8x minus 3a, right? Well, we know that z is equal to this, right? So if I go back and replace it, that leaves me with 4y plus 5b times 8x minus 3a. So basically, instead of factoring out a number or a letter, I factored out a whole expression in parentheses, which looks weird, but it's the same thing. Does that make more sense now? Okay. I probably should have done it on the projector because the virtual kids don't. Okay. So from here, so basically I factored out this whole blue term here. Factored out the whole entire thing. You can treat it like a variable. So let's look at another example. I guess we'll try this one together. So I'm going to put a dotted line down the middle for the sake of finding some things I can factor out. So what can I factor out on the left? Good. So I factor out an x, and that leaves me with 3x plus 2y. And what can I factor out on the right? Good. I can factor out a 5. So positive 5. That becomes 2y plus 3x. So if I erase this dotted line, I now have a full expression. Now, what do you notice about these two? Yeah, they're the same because addition is commutative, right? So it doesn't matter which order I write 3x plus 2y in. It's the same thing as 2y plus 3x. So I can factor out these two terms, right? They're in both. So I can factor this whole thing out right here, here and here. That's going to become 3x plus 2y times x plus 5. So you guys have been you're learning advanced factoring now. You guys are doing a good job with it. Are you guys ready to look at the next one? Or do you guys have any questions on this first?
I still don't understand the one that you did before this one.
Like this, did you understand this one?
Yes.
Okay.
The other one, like, I'm confused. Like, where did you get did you just put the 8x into the factor?
So I factored out this whole thing, this whole blue part, out of both of them. So when I do that, all that's left is 8x minus the 3a.
Oh, so you just...
I just pair them together because I factored out the whole entire expression.
Okay, that makes sense.
Okay. It's weird. It doesn't look like, it's sometimes hard to see. Alright, so let's try this one down here. So what can if I split it down the middle, what can I factor out on the left? Good, 6a. And that leaves me with 3. Good. And what about on this side? Good. I can factor out a positive 8b. It's helpful when you factor out, in this case, that you put a positive sign there. Thank you. And that's going to leave me with 6 Oh, you were in testing?
Yeah.
Okay. So that's going to leave me with 6 minus, 8y. I made a mistake here somewhere, didn't I? Yeah, I did. This is 3. Over here, we can factor out something bigger out of these two, can't we? I think we can factor out a 12. Yep. So we didn't factor out something big enough. So, no, you can't factor out a 12 because
Oh, because 5 times 7 is 6.
it's not. Yeah, so we can factor out. Yeah, it's just 8, I think. That's the biggest one. So this one, no, there's something else you can factor out. Oh, 16. Aren't they both divisible by 16? Yes. We can factor out a 16 over here instead. That's going to make it better. Yep. So over here we can factor out 16b, positive 16b, which makes it 3 minus 4y, which that works out better, right? Because now we have the same thing to factor out here and here. So we can drop our dotted line, and now we can see what both terms have in common. So I have this term and this term, and both of these terms have a 3 minus 4y that I can factor out. When I factor that out, I get 3 minus 4y times 6a plus 16b. The last one's kind of tricky. We gotta talk about that one.
Would you have to factor out the 6 and 16 and
Oh, you have a good point, yeah. We could factor out a 2 out of those two, right? Yeah, so it's actually not, yeah, you could factor out a 2. So if we factor out a 2 out of these two, I'm going to bring the 2 way over here just because it looks better. And that's going to become 3a plus 8b, so good catch. We weren't fully factored. Now we are.
Wait, what?
So Giovanna just pointed out that in this term right here, both of these were also divisible by a 2. So to fully factor, we can also factor out a 2 out of these two right here to make it completely factored. Alright, you guys ready to try the next one? Alright, let's try this one. So this one is a little bit more complicated. Alright, so I'm looking at the first two terms, and I see the only thing I can factor out is a 10. I can't factor out any letters. And if I look at these two terms, I can only factor out a 20 and no letters. So I'm thinking, let's rearrange this. Because if I put these two together, I can factor out an A, right? And if I put these two together, I can factor out a B. So I'm going to rearrange this to be 30 AC plus 40 AD plus 60 BC plus 80 BD. So I just rearranged it, and I rearranged it because I see I want to have variables that I can factor out. Now if you didn't rearrange it, you could still get the right answer, you just have more steps. So from here I'm going to split it down the middle and factor. So what can I factor out on the left now? I can factor out a 10a, and that leaves me with 3c plus 4d, right? And over here, what can I factor out on the right? A 20b, right? So that leaves me with 3c plus 4d. So as you can see, what we're left with when we factor out is the same, and that's what we want, right? So since that's what we want, we can now factor out this whole term right here. So that leaves me with 3c plus 4d times 10a plus 20b. Yeah, you have a point. Now we can factor out the 2 or the 10, right? So we can factor a 10 out of this, right? So that's going to become 10 3c plus 4d times a plus 2b. Good job. You guys are getting the hang of it really well. So moving on to the next few things we have to talk about. Hope we have enough time. Let's see. So let's solve using AC method. Now AC method is basically what I just showed you guys on the last lesson. So what you have to do here before you can do anything, you need to get everything to one side. So I'm going to add the 20x to both sides. That's going to leave me with 4x squared plus 20x minus 56 is equal to 0. And I rearranged it in this order because I want it to be ax squared plus bx plus c format. You guys see why I put it in the middle there? Now, is there a GCF in this case?
Mm-hmm.
What is it?
4x.
Just 4. So when I divide everything by 4, I'm left with 4 times x squared plus 5x.
Why is it just 4? Can't you divide
The last term doesn't have an x.
Oh yeah, I forgot I wasn't looking at that.
So then from here, I can now find factors of negative 14 that add up to what? Good. Good. Good, yeah. Positive 7 and negative 2. So once you get the hang of it, you don't have to write them all out. I just show you that in the beginning. So this is where it's a little bit different. Now we have to use the zero product property. So one thing I want to mention that always throws students off. Now they see that they have to set this equal to 0 and they have to set this equal to 0. With this right here, I can't, if I set this product equal to 0, nothing's going to happen. It's a null. It's 0 equals 4. Don't worry about that one. You can set it equal and you just see it's a rejection because it doesn't make sense. So we're going to set each of these products equal to 0. So when I do that, I end up with 4 is equal to 0, which is null. It doesn't mean anything. I get x plus 7 is equal to 0, and I get x minus 2 is equal to 0. That means that here this is x equals 2, and this is x equals negative 7. So my two solutions are, you put the 0 for the y, and my two solutions are negative 7, 0, and 2, 0. So it's basically what we did on the last lesson, but we do that additional step of setting things equal to 0. That's the difference. All right, are you guys good on example 3? We'll try another one. Let's try example 4. So example 4, do we have a GCF? No. But we have a weird negative sign in front of the x squared, which kind of can be a problem. So I'm in this form, but my a value is not 1. But I can make it into a 1 by factoring out what out of this whole thing? Good, I can factor out a negative 1 out of this whole thing, in which that will fix my issue. So that's going to become x squared minus 14x minus 32 equals 0. So factoring out that negative is going to help make it easier for us. Now from here I'm looking for factors of negative 32 that add up to negative 14. So I'm thinking that's going to be good, negative 16 times 2. So that's negative 1, x minus 16, x plus 2 equals 0. This, I set each piece equal to 0. Negative 1 equals 0, null, doesn't mean anything. X is equal to 16, and x is equal to negative 2. I just skipped setting it equal and did the solutions. You'll get more comfortable with it as you keep doing it and do the same thing. So those will be my solutions. So you always set this whole thing equal to 0, and I just did the solving part really quick in my head. It's just x equals 16. Okay? So So we're going to skip try for now because I want to make sure we cover everything. So the next thing I want to talk about is solving by difference of squares. We'll do a few of these examples. So for the first one, we talked about how to do these earlier, right? You write, if it's difference of two squares, you write it in parentheses. You put a negative and a positive, and you take the square root of each of those. So what's the square root of 25x squared? 5x. And what's the square root of 49? 7. I have to set each of these two equal to 0, zero product property. That's 5x minus 7 equals 0. That means x is equal to 7 over 5. And then over here, I'm going to do the same thing. 5x plus 7 equals 0. I subtract 7 on both sides. I get 5x is equal to negative 7, which means x is equal to negative 7 over 5. That means that my two solutions are 7 over 5, comma 0, and negative 7 over 5, comma 0. It's just because, like, why do I keep it in a fraction? If you want, if it's, I don't know what it is off the top of my head, but if you want to put it as a decimal, as long as it's not a repeating decimal, that's fine. I just kind of just leave it like that. You could also write it as a mixed number if you wanted to, which would be 1 2/5, I think. Alright, so the next one over here, let's do example 6. So this one is not going to be as nice. So I have a negative and a positive. What's the square root of x squared? Just x. What's the square root of 5? Does it take a square root? No, you just leave it as a square root, right? You can't do anything with that. So to solve this, I set each of these equal to 0, and I get x minus square root of 5 is equal to 0. Well, I add square root of 5 over, and that just means x is equal to the square root of 5. And then over here, I'm going to do the same thing. And if you put square root of 5 in your calculator, you'll get a decimal. And that's fine if you're going to graph this, you can use the decimal. But when you're writing solutions, you're going to leave it as a square root, because the decimal approximation is not going to be exact. So if you end up with a square root, you just leave it as a square root, unless otherwise stated. It might say to round to the nearest hundredth or something like that. That's when you would actually round it. So last thing we're going to talk about is roots going backwards. So this is pretty simple, this part. It's the easiest thing on here. So we're going to work with the given roots, and we want to find the equation of the quadratic that would give us those roots. So how you do this is, now what do you notice happens when you find the roots for anything? So see how down here, there's not a perfect example of this, but see how in the equation it's minus 16 and it becomes a positive, and if it's plus 2 it becomes a negative. So what do you notice happens to your roots? The signs switch, right? So that's the same concept we're going to use right here. So if I want to write this back into two binomials, that's going to become the opposite sign. Okay, they're going to flip. And this would be the equation of the quadratic in factored form. So this is the equation for the quadratic in factored form. Now if you wanted to find it into standard form, you would have to use FOIL here. You would just FOIL this out and you'd get standard form. So I will show you how that looks. What? You have until 36. So that's x squared plus 2x plus 1/4 x plus 1/2. And then that would become y equals x squared. Of course, this one with a fraction in it right now. That's going to be plus 2.25x plus 0.5. So these are both the equation, but they're written in different formats. This is what we call factored form, and this is standard form.
So where'd you get all that? Where'd you get the 2.5 or the 2.25 and the 0.5?
I just converted it to a decimal, so 2 plus 1/4. I know 1/4 is 0.25, so I just
you're just combining like terms.
exactly.
Okay.
And I just changed the 1/2 to, because it bothered me to have one fraction and one decimal, so I just put them as. Now, what these roots mean and how these roots translate to factors is basically what they're looking at is they want you to rewrite it as like I think they're looking for an ordered pair. So the ordered pair of those roots would be negative 1/4 and negative 2, 0. What'd you say? You're right if we put it in their factors, but here this is just writing it as an ordered pair solution. So they stay the same as the roots there in that original one.
So for every problem we can just write for the factors, just put those in ordered pairs.
If they're asking for it, the actual factors themselves, like this is the equation part, right? And if you were to solve this, you would have set this equal to 0, and then you would have gotten these as your solutions, basically.
Is there any way where, like, we can't just look at the problem and go, like, look at the roots and put them as the factors, right? Are they all going to be the same every time?
For this, yes, but for the equation, no.
For the equation, yeah.
The equation's more complicated. But yeah, the factors is the same thing.
Okay, so you just, like, for the next one, the factors would be 3 and 4/5.
Yes, the answer written in order pair form.
Yeah.
Yes.
So like 3, 0, and then 4.
I'm just wondering because technically that the word for this isn't really factors, it's just zeros. Factors are going to be like the two, like this, x plus 1/4 and x plus 2. Those are the actual factors, but the zeros are when you write them as the ordered pair. The factors are the two pieces we set equal to each other. I mean, set equal to 0, yes. So for the next one over here, we would do the same thing to write the equation. If we want the 0, I should write it on a separate line, the zeros, because I don't want to throw anybody off with that terminology. The zeros are just going to be 3, 0, and 4/5, 0.
Can I put that in factors or?
No, put it as zeros because I don't want anybody to be thrown off by that. Because I just don't like the way this activity.
We just scribble out factors?
No, just wait. I'm going to go through the whole thing. All right, so for the next part, we're going to write the factors. Okay, so the factors are going to be x minus 3 and x minus 4/5. Now the equation is always y equals your factors, which is x minus 3 and x minus 4/5. And to get the actual equation, you would use FOIL here to get it into standard form. So you can try out the FOIL if you want. I'm going to leave it like that. This is what we call factored form. So I just thought it was weird the way that the lines were, because it was like basically telling me to write the same two things twice. So I just wanted to clear that up. So that's everything. I know it was like long today because it's a Wednesday and it's also kind of like a lengthy lesson. So that's just the way it is with block scheduling. We can't really avoid it because otherwise we'd be off for 3 days. So do you guys understand what we did today, hopefully? Okay.
Is there like a homework for this? For this lesson?
So both those homeworks are due on Friday. So you have a homework for each section, but it shouldn't take that long. They're pretty short.
Is that one homework you said?
What?
Not tomorrow.
Yeah, I gave